What if I told you that the massive steel bucket attached to an excavator is not just a simple tool, but a piece of engineering designed to withstand extreme forces, crushing tons of rock, soil, and debris every single day without failure? Inside heavy industrial factories, billions of excavator buckets are produced through a complex process that combines intense heat, powerful machinery, and absolute precision, transforming raw steel into one of the most essential tools in construction and mining. The journey begins with high-strength alloy steel, a material specifically engineered to resist abrasion, deformation, and impact under extreme working conditions. As these buckets must endure constant friction against hard surfaces like rock and gravel. Massive steel plates arrive at the factory in different thicknesses and grades, where they are carefully inspected for imperfections, measured with precision instruments, and selected based on strict engineering requirements. Because even the smallest flaw in the material could lead to structural failure once the bucket is put into operation. Once approved, the steel plates are transported into advanced CNC cutting stations, where plasma torches or high-powered laser systems slice through the thick metal with incredible accuracy, generating intense heat and showers of sparks as each piece is cut into its designated shape, including the base plate, side walls, and internal reinforcements. This stage is critical because precise dimensions ensure that all components will fit together perfectly during assembly, minimizing structural weaknesses and maximizing durability. After cutting, the flat steel components are moved to heavy forming machines, where massive hydraulic presses and rolling systems apply enormous force to bend and curve the metal into its final shape, gradually transforming rigid plates into the distinctive curved profile of an excavator bucket, a design that is carefully engineered to optimize digging efficiency, material flow, and load distribution during operation. The shaped components are then assembled through an intensive welding process, where skilled workers and robotic welding arms fuse the metal parts together using high-temperature arcs, creating strong and permanent joints. Additional reinforcement plates are strategically added to areas that experience the most stress, ensuring that the final structure can withstand extreme mechanical forces, repeated impacts, and long-term usage without cracking or deforming. To further enhance durability, the assembled bucket undergoes heat treatment, a process in which it is placed inside massive industrial furnaces and heated to extremely high temperatures until the metal structure changes at a microscopic level, after which it is rapidly cooled in a controlled process known as quenching, followed by tempering to balance hardness and toughness, resulting in a material that is both strong and resistant to wear. After the heat treatment process, the hardened steel components are not yet complete, as they must undergo further shaping and refinement to achieve the final geometry of an excavator bucket. Using precision machining tools, grinding systems, and forming equipment, each section of the bucket is carefully adjusted, including the curvature of the shell, the alignment of the side walls, and the structural angles that determine how the bucket penetrates and holds material, ensuring that every detail is engineered for maximum efficiency, balance, and durability during real-world operation. Once hardened, the bucket is fitted with cutting edges and teeth, which are among the most critical components as they directly interact with the ground. Breaking through tough materials like rock and compacted soil, these parts are typically made from specialized alloys designed for maximum wear resistance, ensuring that the bucket maintains its performance even in the harshest working environments. After the bucket teeth are installed, the assembly process is still not complete, as multiple additional components must be fitted to transform the structure into a fully functional excavator attachment. Mounting brackets, hinge joints, side cutters, wear plates, and reinforcement elements are carefully installed and aligned, allowing the bucket to connect seamlessly with the excavator arm while also improving durability in high-impact areas, and every detail is adjusted with precision to ensure smooth movement, balanced weight distribution, and long-term reliability under extreme working conditions. Before completion, the entire bucket is cleaned and coated with protective layers, including anti-corrosion paint or powder coating, which shields the metal from rust, moisture, and environmental damage, while also giving the product its final industrial appearance, ensuring both functionality and longevity. In the final stage, every excavator bucket is subjected to strict quality inspections, where engineers test its dimensions, weld integrity, and structural strength using advanced measurement tools and stress tests, and only those that meet rigorous industrial standards are approved for shipment to construction sites and mining operations around the world. From raw steel plates to a fully engineered industrial tool, the journey of an excavator bucket is a powerful demonstration of what modern manufacturing is capable of achieving, where extreme heat, immense force, and precision engineering come together to create a product that must perform flawlessly under the harshest conditions on Earth. Every cut, every weld, every adjustment plays a critical role in shaping a structure that will dig, lift, and endure millions of cycles without failure, proving that even the most rugged machines are the result of careful design and advanced technology. And while these buckets may seem like simple attachments on the surface, behind each one lies a complex process driven by innovation, efficiency, and relentless industrial mastery, allowing factories around the world to produce them at an incredible scale. Billions of units that power construction sites, mining operations, and infrastructure projects across the globe. So the next time you see an excavator at work, remember that its strength does not come from size alone, but from the unseen process behind it, a process forged in fire, shaped by machines, and perfected by human ingenuity.